Fine, good afternoon to you all students. Hi students, how are you? I hope you all are fine. Students, are you studying daily portion? Students, are you revising daily portion? So please study daily portion, okay? So welcome to our today's online class students. So now we are studying about chapter 8, isn't it? So what's the title of our chapter? Iteration and recursion, isn't it? So in this chapter we are studying about iteration as well as recursion. So what do you mean by iteration? So if you are going to solve some problems, so some problems you need to solve the same steps repeatedly or again and again. We are calling that process as an iteration, isn't it? Then what do you mean by recursion? So if you are going to solve the problem, so each problem will have some inputs. So you are taking input. From the inputs you are taking only part of the input to the problem and you are getting solution for the original problem. That process we are calling as an recursion, isn't it? So and next in this chapter what are things you have studied? Invariants as well as loop invariant. What do you mean by invariant? So before, if you are going to solve the problem, just like a LHS equal to RHS. So before you are making any modifications, so you are getting some value as the answer. So before the modifications and after the modification, you are getting the same value, means you can say that as an invariant. So what do you mean by loop invariant? So inside the loop, at 4 points, the loop needs to be true, isn't it? So what are the 4 points? Are you remembering? So at the start of the loop it becomes true. Then at start of iteration it becomes true. Then at the end of the loop it becomes true. And end of each iteration it becomes true. So these are the things you have studied in the last class and before that class, isn't it? So last class we have studied about invariance example, isn't it? So last class we have studied 3 examples. What are the example problem we have studied? Problem to calculate power a power n, then chocolate bar problem, then trees, the birds sitting in the trees. So 3 problems you have studied. So I asked you to study the 3 problem and I asked you to write in your notebook also. So have you all studied that problems? So please study daily portions. This 3 chapter 6, 7, 8. First itself I am telling this is a fully raw theory, very tough. So please study daily portions. Okay. Yes, today also we are going to study about one example for that invariant problem. 1 or 2 examples for invariant problem. Next we are going to study about recursion. Understand? So listen. So first problem is the Chamberlain's of Cromland problem. So already you have studied about Chamberlain's of Cromland. So what's the problem? 2 chapters continuously you are studying about this problem. So in a country of Cromland, so a lot of Chamberlains are there. So here 3 kinds of Chamberlain. That means 3 different colors of Chamberlains are there. So what's the problems means? These 3 colors. So they will consider some meetings among them. Okay, they are conducting some meetings among them. So in this meeting, this arrangement of meetings, any 2, that means 2 different colors of chamberlains are equal in number. For example, here they are giving 3 colors. What are the color means? Red color, green color and blue color. So among these 3 color, for example, 2 red color and 2 green color, if consider they arrange the meetings between them, means that these 2 colors will change to the next color as a blue color. Understand? So what's the question they asked means, at last, whether it is possible to display all the chamberlains in the same color or in blue color. What they are asking, it is, if it possible to, if they are conducting meeting, arranging some meetings, it is possible to display all the chamberlains are in blue color. Understand? So in your question they have given, so listen, how many red color chamberlains are there? 13. So how many green? 15. And blue? 17. Okay. So now we are going to solve the problem. Understand? So listen. So here red, green and blue. How many chamberlains are there? Three color. What are they? Red, green and blue. So to represent the red color, we are giving, so here we are declaring three variables for representing these three colors of chameleons. Okay. So R, G and B. So R represents red color, G represents green color and B represents blue color. Understand? So we are going to find out. So in question what they have given? If they conduct meetings of, then that means any two types, if they conduct or arrange meetings among them, means they will change to the third color. So we are going to model this process an iterative. What do you mean by iterative? That means same process will repeat again and again. That is called iterative. So you are going to arrange the meeting between two types of chameleons as an iterative process. Understand? So listen. So how many chameleons are there? How many colors of chameleons are there totally? Three colors. What are they? R, G and B. Red color, green color and blue color. Listen. So among these, one chameleon from red color and one chameleon from green color are conducting arranged meeting between them. Then what's the condition? If two different colors of chameleons arranges meeting between them, if they changes to, if their two colors are in equally number, if they conduct meeting means or arrange meeting between them means, automatically these two color chameleons are changes to the third color. That means to blue color. Isn't it? So listen here, consider, listen carefully. First, so how many chameleons are there totally? How many colors? Three colors. R, G and B. So R minus 1. What's the meaning? Means among red color, one chameleon and among green color, one chameleon are arranging meeting between them. What are they? So red color, from the red color, one chameleon and from the green color, one chameleon. So among the, so only R minus 1. Totally 13 red color means, so one from red color is going. So 12, remaining 12. Understand? So consider for G color, green color, 10 chameleon is there means from the 10, one conducting meeting. So red color, from red color 1 and green color 1. So you are reducing the total red color from 1 and reducing the total number of green color from 1. Understand? So R minus 1 and G minus 1. So conducting meeting means that two of them will change to which color? Blue color. So B plus 2. This 2 will join to which color now? Blue color. Understand? From the red color 1 and the green color 1. So these two are now equally number 1 from red 1 as well as green 1. Conduct the meeting between them. So among these two arrange the meetings, they will automatically change to the blue color. So which one need to increase now? Blue color, B plus 2. Understand? This is the one possibility. Another one possibility. What's another one possibility? From red color 1, R minus 1 as well as blue color from 1. These two are conducting meetings, two different color. So these two change to which color? Green color. So G plus 2. This two from this red and blue will join to green color. Understand? Same wise another one possibility. From green color 1 as well as blue color 1 conduct the or arrange a meeting between them, automatically change to which color now? Red color R plus 2. So these are the three possibilities are there in this chameleon's problem. Okay. So understand now, if they conduct the meetings or arrange meeting between them, that means two different colors are equally number. So here see red color from 1 and green color from 1. So two different colors but equally number 1 1. So then they automatically change to which color? Blue color. So B plus 2. Likewise red color from 1 and blue color from 1. So automatically change to green color. So likewise red color 2 and green color 1 and blue color 1 automatically change to red color. So it is joined to the red color. Understand? So listen. So these are the three possibilities are there to conduct meetings between them. So here they are giving in your example they are giving. So arranging meeting between red and green chameleon. Okay, these are the three possibilities. Among these three possibilities, any one you can take and solve the problem. Okay, listen. So first what they are giving, arranging meeting between whom and whom? They are arranging meeting between red color as well as green color. So listen, R, G, B. So from red color, arrange meeting between red color and green color. So R minus 1 comma G minus 1. So from the red color one and the green color one is arranging mating between them. So it automatically will join to which color? Blue color. So B plus 2. These two persons are adding to which color to now? Blue color. Understand now? Yes. So likewise, we are going to solve this problem by the three possibilities. Already in a question they have given some values, isn't it? So by these three possibilities, whether we can prove this is an invariant or not. Okay. So three possibilities already you have written. So from these three possibilities, you have taken only one. So arrange meeting between whom and whom? Red color as well as green color, isn't it? So among these, you are going to, among these three possibilities, you are going to find out whether this is an invariant or not. Okay. So here what they have given means, so read the first line. Difference in number of any two types. So if any, from the any two colors, they are difference in number mean, do not change or changes by 3. So third color need not to change anything. So only if we need to add to the third color. So you are not going to change the third color. Understand? So how we can say this is an invariant? Listen, first you are subtracting first two. Or that means red color and green color. Red color from 1 and green color. So R minus 1 minus G minus 1. The same example you take, okay? Listen, same example. First you are reducing this R minus 1 minus G minus 1. For first this 2 type. Then next G minus 1 minus B plus 2. Next B plus 2 minus R minus 1. Among these you are going to subtract 2 meetings. Okay, listen. So first R minus 1 minus G minus 1. First you are subtracting first two terms. Okay. So remove the bracket. R minus 1 minus G minus plus 1. So minus 1 and plus 1 get cancelled. You will get the answer R minus G. So red minus green. Second thing. So R minus 1 minus B plus 2. The same question from that. So you have given no one the expression. From that expression you are going to subtract these two terms. Understand what I am telling? So here you are taking one expression. How? Meetings between red color and green color. First you are going to subtract these two terms. Okay. Listen. R minus 1 minus G minus 1. This 2. Next R minus 1 minus B plus 2. This 2 term. First this 2 terms. Next first and third term. Next second and third. G minus 1 minus B plus 2. So among this you are going to solve whether you can say this is an invariant or not. Now understand? So see, next thing. R minus 1 minus B plus 2. Remove the bracket. So R minus 1 minus B minus 2. Okay. So what you will get? R minus B. Minus 1 and minus 2. The answer is minus 3. Same thing next. G minus 1 minus B plus 2. Remove the bracket. G minus 1 minus B minus 2. So G minus B minus 1 and minus 2 minus 3. So likewise 3 possibilities you are given in the question, isn't it? Likewise, if you are solved like this 3 possibilities, all the 3 cases, you will get the answer like this. So from these, any 2 types is differ means, so you can get the multiple of 3. Only 2 of them are getting multiple of 3. Third one is getting 0. So they are given, see, the difference can be reduced in steps of 3. So 2 only you are getting the multiple of 3 and 1 process you are getting 0. So when we can say, and when we are getting the 0, the process is ends. Understand? So listen, in your question, they have given some values. For R, they are given 13, the value of G is 15 and value of B is 17. So you are going to subtract these values. So R minus G, what's the value of R? 13. What's the value of green? 15. 13 minus 15. What answer you are getting? Minus 2. Likewise, G minus B. The value of G is 15 and value of B is 17. 15 minus 17. Answer you are getting as minus 2. Next, B minus R. The value of B is 17. The value of R is 13. 17 minus 13. The answer you are getting is 4. Okay. So, whenever you have conduct meetings like this, only any 2 colors you can get the answer as same. But the third color you are not getting the answer as same. So, in a question they asked whether at last, whether all the colors are displayed the same. But It is not possible to display all the colors the same because anyhow you are reduce the values. Only two colors are getting the same value but the third color is getting different value. So you can say this problem you can't able to get the same color. All the chameleons is can't able to display the same color. Understand? So somewhat tough, just think and study. So one time just go through it, this problem, just one time read it. So three possibilities, then assignments, then this subtraction. Just once read it, this problem. Read fast. So I will read the problem. Yes. So next example is jar of marbles problem. Okay. So what's the problem next? Jar of marbles problem. Listen. So in this problem, consider you have one jar. Okay. You have one jar or basins or bottles, anything. So in that jar, full of two kinds of marbles are there. Okay. So you have one jar in your hand. So in the jar, there are totally two kinds of marbles are there. One is white color marble and one is black color marble. Okay, you are going to play this game. So what's the game means? Listen, you have one jar. So in that jar full of two kinds of marbles. What are the color of marbles? White color as well as black color. You are going to play this game. What's the game means? Randomly, as per your wish, you can take any two marbles from the jar. Okay, any two colors you can take. Okay, so randomly you can able to select any two marbles from the jar. Okay, so what's the condition means? If you are picking two marbles, no, if the marbles are in same color. So already you know in the jar consists of two kinds of marbles, white color marble as well as black color marbles. If you are going to pick two, randomly you are going to take two marbles, either black color marble or white color marble. But what's the condition is, in your hands, if you are picking some marble, no, in your hands, if the marble are in same color, two marbles are in same color means you need to listen carefully. If two marbles are in same color, either the marbles are in, two of them are in black color or two of them are in white color. If two of them are in same color means what you need to do means, so you need to throw the two marbles outside. Understand? If two marbles, you are picking two marbles, no? If the two marbles are same color means either two marbles are in black color or in white color. If the two marbles are in same color means you should throw the marbles outside, but you need to place a white marble. Sorry. So if you get two same marbles of same color means you need to throw the marbles outside, but you need to put another one black marble into the jar. What's the game now? Understand? If you are picking any two marbles, so in your hand, suppose you are picking the same marbles are in same color means, for example, two white marbles or two black marbles. If the marbles are in same color means you should throw the two marbles outside, but you need to get another one black marble and put inside the jar. Understand? This is the first condition. Next condition. If you are picking two marbles, but if the marbles are in different colors means, for example, one marble in black color and one marble in white color means, so what you should know means, so you should place the white marble again into the jar. You need to put the white marble again into the jar, but you should throw the black marble outside. Understand the game? Now understand what's the game? You have one jar. The jar, consider the jar full of marbles. That means two kinds of marbles, white marble as well as black marble is there. You are going to play a game. What game you are going to play means randomly you are selecting two marbles from the jar, or you are going to pick up two marbles from the jar. Maybe a black marble or white marble or black and white marble. Condition is if you are picking the two marbles are in same color. That means either two marbles are in black color or the two marbles are in white color. If you are picking the marbles, that marbles are in same color means you need to put the 2 marbles outside. You need to throw the 2 marbles outside, but you should place or you should pick another one black marble and put inside the jar. They will give lot of marbles for you. Among that, you need to take any one black marble and again you need to put inside the jar. That when you need to put, if you are getting 2 same colors. If you are getting 2 different colors means you should place the white marble again into the jar. So if you are taking the marble, the 2 marbles, one marble is white color, another marble in black color means you should place the white marble again into the jar and throw the black marble outside. Understand? So in what question they ask means, so at last which marble is left in the jar? So at last, likewise if you are picking and throwing outside, at last which marble is left in the jar? Maybe a white color or a black color. Understand? Listen. So same thing they have mentioned in a diagram. So consider this is a jar. Okay. So this jar consists of lot of marbles, 2 types of marbles. What are they? Don't consider only 2 white color and 2 black color marbles. For your understanding they have given like this. Okay. So this is a jar. The jar consists of lot of marbles, 2 kinds of white marble as well as black marble. First, 3 possibilities are there here. What are the possibilities? First, if you can, what's the thing? First, you need to pick 2 marbles, isn't it? First, if you are picking the 2 marbles, the first 2 marbles are in same color. That means 2 are in black color means. What's the condition? If they pick, if first you are picking 2 marbles, if the marbles are in same color, what's the condition? Whatever you are picking, you need to throw these 2 marbles outside. But you should place another one black marble inside. See? So you are picking 2 black marbles from here. Consider. You are picking 2 black marbles here. So there is no more black marble, isn't it? So what's the condition? If you are picking the marbles that are the same color means you should throw these marbles outside and again you need to place the black marble inside the jar. Understand? Next thing. What's the thing? So if you are picking 1 black marble and 1 white marble. So among this you have picked 1 black marble as well as 1 white marble. Okay. So if the condition is 2 are different colors. What's the condition? If 2 of them are different colors means you should place the white marble again. Okay. If these 2 marbles you have picked 2 different colors. What's the thing you need to do? If 2 different colors means you should place the white marble again inside and throw the black marble outside. Understand? Then, next, if you are picking, so the 2 marbles are in white color. Okay, these 2 marbles you have picked. So, what's the condition? If 2 of them are same color means throw them outside, put the black marble inside. So, you should place the black marble inside. Understand the same thing they have mentioned in the diagram. So, to solving the problem, how many types of marbles are there? Totally 2. What are they? White marble as well as black marble. So, you are representing this white and black marble by 2 variables. White is represented by W and black is represented by B. Understand? So, you are represented by 2 variables. What are the? White is represented by W and black is represented by B. Okay. How this process get changed? So, here there are 3 possibilities are there, isn't it? So, based on that, the color of the marbles becomes changed. Isn't it? How the color of the marbles become changed? Based on the possibilities of picking you. How many marbles you are picking or which color you are picking. Based on that, depending on the colors you are picking. So, based on that, the marbles colors also change. So, that one you are going to write in a iterative step. Okay. How the colors of the marbles are changing or how many colors you are taking, how many number of marbles you are taking and what color of marbles you are taking. Based on that, the process will get changed. For that, you are going to write an iterative algorithm. Understand? So, what are the 3 possibilities are there? Either you can take 2 black marble or either you can take 2 white marble or either you can take black or white marble. Same thing they have mentioned in this diagram. Understand? So, now we are going to write the algorithm for this. Listen carefully. First thing, at least 2 marbles in the jar. So in a question itself they have given in a jar consists of lot of marbles. That means 2 different marbles. If you need to pay 2 kinds of marbles from the jar means the jar should have at least 2 marbles. Then only you can able to pick the marbles from the jar, isn't it? That's the first thing. So they are giving while at least 2 marbles in the jar. So what are the 2 marble colors? Black as well as white. So for that they are giving the black is denoted by B and W is denoted, white is denoted by W. At least 2 marbles. If you need to play the game, if you are going to play the game, what's the condition? At least 2 marbles should be available in the jar. So what are the 2 kinds of marbles? Black and white. Understand the first 2 lines? Yes. So next you are going to taking any 2 marbles from the jar. So next step. First you are taking case both are black. If you are taking which marble? Both cases are black. So they are denoted B, B, B. What do you mean by B and B? 2 black marbles. First thing you are taking 2 black marbles. What's the condition if both the marbles are in same color means? Both the marbles are same colors mean. So you need to throw away that marbles. Again you need to put the black marble inside the jar. Isn't it? So consider if this case is both are black means that are same color. What you should do? Throw away the both marbles. This 2 marbles you should throw away, but you need to put black marble inside the jar. Understand till 6th line? Listen. So listen. B equal to B dash minus 1. What's the meaning means? 2 marbles you are taking. Isn't it? 2 marbles you are taking from where? Which color? Black color. So if the condition both are the same, you need to put the black marble again you need to put inside the jar. So listen. So black. So which color you are taking? Black. So B dash minus 1. Understand? But white is remains the same. You are not taking any white. So W equal to W dash. Okay. B dash and W dash represents which marble you are taking outside. That is represented by B dash and W dash. Okay. Marbles you are taking outside. No? That is represented by the variables B dash and W dash. Okay. So here from the black only you are taking the marble. So B dash minus 1. But white you are not going to take. So white is remain the same. So W equal to W dash. Next you are going to add both this one B plus W. What answer you will get? B dash plus W dash minus 1. Understand? You are going to add this two. B plus W. What answer you will get? B dash plus W dash minus 1. Understand this line? Understand? Yes. This is the condition for both the cases are black. Next, if both the cases are white. Understand? If both the cases are white. What's the condition if both the cases are white means? Same. If 2 of them are same color. Isn't it? So if 2 of them are same color means, so you need to throw the marbles outside. Again you need to put the black marble put inside on the jar. Isn't it? So listen. So from which marble you are taking outside? White. How many marbles? 2. So W equal to W dash minus 2. From the white you are taking 2 marbles outside. Understand? W equal to W dash minus 2. That means from the white marble you are taking 2 marbles outside. But what's the condition? If you are taking 2 marbles outside, we need to put the black marble again inside the jar. So B equal to B dash plus 1. Again you are putting the black marble inside the jar. So you need to add. Understand? But here, consider this. Here you have taken 2 marbles outside. Okay, you have taken already 2 marbles outside. So B dash minus 2 will come. So 2 marbles you have already taken outside. But you need to put a black marble inside. So here one step will come. So if you are getting confused means please write here. Okay. So consider. So you are taking 2 black marbles outside. So you are taking 2 black marbles. B dash minus 2. Okay. But condition is again you need to put the black marble inside. So plus 1. Minus 2 plus 1. What answer you will get? Minus 1. Likewise only you will get the answer B dash minus 1. Understand what I am telling? So you are taking the black marble out, 2 black marble outside. So B equal to B dash minus 2. Okay. But again what's the condition? If 2 of them are same color means again you need to put the black marble inside. So already you have B dash minus 2. You need to put the black marble inside. 1 marble. So B dash minus 2 plus 1. What's the answer you will get? B dash minus 2 plus 1. Answer you are getting B dash minus 1. Likewise only you will get the answer. Understand? But here, so here you are taking 2 white marbles. So what's the, so W dash minus 2. So W dash minus 2. What's the condition? You need to put the 2 of same color. You need to put the black marble again inside. So B dash plus 1. So now add this one. B plus W. Add it. B dash plus W dash. So plus 1 minus 2. Plus 1 minus 2. So what answer you will get? Minus 1. Understand? Next. Else, next condition is if you are taking 2 marbles of 2 different colors. What are they? B and W. Both are black and white. What's the condition if 2 different colors means? 2 different colors means you need to throw the black marble outside. So you need to throw the black marble outside, but you need to put the white marble bags. 2 marbles you are taking. What are the marbles? Black marble as well as white marble. What's the condition? If 2 different colors means you should throw the black outside as well as you need to put the white inside. Understand? Listen. So you are taking one from black and one from white. Isn't it? So what's the condition? Black one you are throwing outside. So one you have taken from black. So B dash minus 1. So already you have taken. So but what's the condition? You have taken black. So B dash minus 1. Okay, once you have taken. But what's the condition? You need to throw the black one outside. Next, you need to put the white one back. Okay, so how it will come? You have taken one white marble outside. So W dash minus 1. Here it will come W dash minus 1. But again you need to put the white one back. So W dash minus 1 plus 1. Minus 1 and plus 1 will get cancelled. Answer you are getting W equal to W dash. Understand what I am telling? Now add it B plus W. So add it B dash plus W dash minus 1. So see, at last all the answers you are getting B dash plus W dash minus 1. Understand this algorithm? Understand? Somewhat tough only. Please understand and study. Otherwise, surely you will get confused. Okay? So listen. What they are telling means. So each cases you have seen means. So this B plus W. So you can see the change. How the changes are done in B plus W. Isn't it? So either the value of B is decreases by 2 or the value of W is decreases by 2. That means sometimes decreases by 2, sometimes decreases by 1. Why? If 2 cases are white means W minus 2. If 1 case is white means W minus 1. Otherwise 2 cases are black means B minus 2. Otherwise 1. So either the numbers will be a odd or even. That means parity. Odd or even. You are getting odd or even. Okay. So now we are going to say this parity W. You are going to consider this W. Okay. So they are saying the W means white color. Either the value W is decreases by 2 or 1. So the parity we can say either it is odd or even. But so the value of W will not get changed. So we can say this is an invariant. Okay. So at the end of the game, they are giving still the game and the value of W is even only. They are telling still end of the game, the value of W will be even. Either W equal to 0 or W equal to 2. Okay, listen. So, last they are giving only one marble is left in the jar. How many marbles are left in the jar? Totally 1. That is W plus B equal to 1. Either W equal to 1 or B equal to 1. Or W equal to 0 or W equal to 1. Okay. But you are giving W is still even. So, listen. At the end of the loop, what's the condition? W plus B equal to 1. Only one marble is left. That is W plus B equal to 1. That means, from this we can say only one marble is left. But you are giving W is still even. Even means the value of W equal to 0. Isn't it? Or we can say B equal to 1. So, W even. W is even you are saying. So, what value only we can take? W equal to 0. If W equal to 0 means what's the value of B now? 1. You are taking the value of W is 0. Then what's the value of B now? 1. Okay. So, B equal to 1 means which marble is left at the back? Black marble. Okay. So, at the last end of the game, the marble left in the jar is black color. Because you are giving the white marble, either you can take the 2 white marbles or left one side, so that we can say the value of W is always even parity, so value is W equal to 0, not 1. So if W equal to 0 means what's the value of B now? 1. So B equal to 1 means the last marble left in the jar is black. Understand? Yes. So till we have studied about invariance examples. So a lot of examples we have studied, from this surely you will get one question. Okay. So next thing we are going to study is recursion. Okay. What do you mean by recursion? First topic is over. What is iteration? Till now we have studied about iteration. Next thing is recursion. Okay. So this is also an algorithmic technique. Okay. What is recursion? Recursion also an algorithmic technique. But so this recursion and iteration is almost similar. This recursion and iteration is almost similar. But what's the thing means in recursion? So you are taking, if you are giving some inputs to the problem, so from the input you are taking some part of the input. Okay, you are taking, for solving the problem you are taking part of the input, but at final you are getting solution for the full problem. You are taking the part of the input from the problem, but you are getting solution to the original problem. That we are calling as an recursion. Understand? So listen, for that one example they have given. So customers are waiting in the line in a counter. Okay. So in a counter is there. For example, in a theater, a counter or bank counter, anything. A counter is there. Lot of persons are standing in queue. Okay. So a person who sits in the counter wants to know how many persons are standing in the queue. So what he will do? Simply he will count how many number of persons are standing in the queue, or how many numbers of persons are waiting in the queue. Isn't it? That's a normal thing. But using recursion, you are going to solve how you are going to count the number of customers waiting in the queue. Understand? Listen. Consider there are totally 5 customers are there. How many customers are there? 5 customers are there. Instead of counting 1, 2, 3, 4, 5, how they are performing this recursion. Listen. Consider first person, consider the variable. We are representing the first person as the variable A, second is B, third one is C, fourth one is D, and fifth one is E. Okay. Consider first person as the head of the queue. Okay. So he is asking who is standing behind the first person. Who is standing behind the first person? B. So he is asking the length. What's the length? So he is telling who is standing behind. Who is standing back to the A? B. So B is telling 1. Understand? So his queue length is 1. Next, he is asking the queue length to C. So C is telling back to the C how many persons are standing? 1. So he is telling the length is 1. Next he is asking to the next person D. So he is asking what's the length? He is telling 1. So after the E, any persons are there? Listen, after E, any persons are standing? No. So he is replying, again he is replying to D, what's the length? So he is the last person. Consider, first who is the head of the queue? A. So he is what he was telling, the length is 1. Next, this person over. Next, consider B as the head of the queue. He is telling what's the length of the queue to C? 1. Leave with that person. Next, C is the head of the queue. Leave with this. So he is telling to D, how many persons are there? 1. So leave with the person C. Now who is the length head of the queue? D. He is telling the length of the queue is 1. At last, at the back of the E, nobody is standing. So he is also telling the length of the queue is 1. Behind E, there is nobody is standing. So what's the length? 1. So he is replying to D, 1. Then D is replying. So here 1 is there, no? Already 1. So 1 plus 1. So he what's the answer? 2. So C is replying. 2 plus 1, what's the answer? You will get 3. So C is replying to B. He is telling 3 plus 1. What's the answer you are getting? 4. So B is replying to A. 4 plus 1. So add 4 plus 1. What's the answer? 5. Now A is replying to the counter person. Totally 5 persons are there. Okay. This is a simple only. What we will do? Simply if he has to count how many persons are sitting in the class. What he will do? So you should count all the numbers and you will say the answer. Same thing, but you here each persons are standing behind. So how they are calculating means, consider this is the length of the queue. To calculate length of the queue, consider first person as a queue head. So he is the solver for the problem. So if the length of the queue, first person over, next they are taking only B, C, D as a input. Then after B is replying, leave the person A and B. Next they are solving with the 3 persons C, D. Next the length is over means, next they are solving with the persons D and E. Okay, so like they are solving till the end of the queue and they are finding the answers. Okay, so this is a somewhat biggest problem. So next class we can continue. Okay, so today I have taught 2 more problems in the invariant examples. So after completion of this session, and also I have taught about definitions of recursion. So you should study this Chamberlain's of Cromland problem as well as the loss problem I have taught. That means the jar of marbles. The 2 problems you should study and write in your computer notebook. Okay, so as well as recursion definition you should study. That's a very important question. That's a homework for you. Please don't skip this on. Daily study, daily portion. So within this tomorrow's class I will continue. Remaining portions I will continue. Maximum I will try to complete within tomorrow's class. Okay, next we can continue the second chapter portions. Okay, so thank you students. Thank you, study well.